Hey there guys, I hope that you're doing well. In this video I'm going to be giving you my 6-month super review on the ZWO FF80 Apo along with the matched 0.76 times reducer. I've used this scope as much as I possibly could over the past 6 months. Every clear night I've had it out, been trying to gather some data with it, and I've also pulled in some help from outside to pull this review together as well. So a huge thanks to my friend Bill Blanchard over in Texas for providing me some data from his FF80 Apo as well, which we're going to be taking a look at throughout the course of this review. But first off, I'd just like to say, like any review done on my channel, no money's been switching hands or anything like that. It's all just completely my own views. Whatever I want to say about this thing is what gets said, and that's how it is, that's how it's always been, and that's how it will remain. So a huge thanks to 365 Astronomy here in the UK for agreeing to work with me and get this scope here for this extended review. They're a wonderful company. Special thanks in particular to Zoltan for being such a pleasure to work with as well. So let's jump into the review straight away now. Now, first off, I'd actually just like to tell you a little bit about the pricing, like where it fits into the market, because it's fair to say it's not a cheap telescope. £1,350 here in the UK, along with another £250 if you want the 0.76 times reducer along with it, which for me, I probably would want that if I was purchasing this for myself, as I think it's a pretty good offering. But just the base spec, it really is a wonderful telescope to use in its base configuration. It's coming in, like I say, £1,350. Now the scope's a lot cheaper than this, so if you want to get something far cheaper, something like the EvoStar 80ED from Skywatcher, they're a quality doublet. Compare that with the field flattener and get very nice performance, but mechanically it's going to be quite far behind this thing. Moving up a step from that, you can get quite similar in terms of like focal length. It's not too far off the ASCAR 71F, and that's a good step cheaper again as well, and a lot of people like those things. This is fitting up in the upper middle, I would say, of what's available on the market, and it really is a convincing offering. But if you want to go beyond this, there are a few options available on the market right now, and the one that I would probably go for if you do want to spend more, and it is quite a bit more, another £1,000 basically on top of this, that would be the ASCAR SQA 85. Now, as I say, that's just where it's positioned in the market, and I want to touch upon that straight away. What do you get for your money? Well, you get, of course, the scope. There's no case that comes with these things, and I think there's one thing that's lacking. I'll talk about this a little bit later on in the video too, but it comes only with one finder shoe. I would have loved to have seen two, as there is provision to actually fit a second one onto this, but fair play to them. They're putting out a full frame image circle on this telescope, and that's, you know, it's tested, it's proven. My friend's got some data to actually show us for this, and we're going to jump straight into that as well. So if you do use a full frame camera, you can make it work with this. My personal preference for this, though, and I'm going to provide you data to try and back this up, but I think my personal preference for this is, I think it's at its strongest over an APS-C size sensor, but the full frame performance is still very good indeed. And the spot diagrams really do back up what I'm talking about right there. As you can see, the dispersion of light and color turns into a little bit of a very small, admittedly, but like a snowman kind of thing, a blue base, red tops, and we'll show you a little bit more on that later. And the reduced performance is just a little bit tighter than this, all along the kind of different distribution points that they test for these spot diagrams. But anyway, enough about the spec. You can see there's a heck of a lot going on here, and it is a nice small telescope. If we jump in now, we're going to take a look first off at some completely unprocessed. These are just masters from hydrogen, red, green, and blue. These were taken with a full frame camera from Starfront Observatories in Texas by my friend Bill Blanchard. So this is his data on M78, a bit of Barnard's Loop, and the Boogeyman Nebula just up there. It's this wonderful quality data. But the important thing about this, like I say, is it was taken with a full frame camera, unreduced. So you can hopefully see, if we just zoom into a 1:1 times zoom, I'll just make this one channel a touch bigger for us right here. So 1:1, center sharpness is wonderful. It can stand even going further, of course, and this is before anything's applied, as I say. So BlurXTerminator is only going to make this so much sharper. We will touch upon that a little bit further on as well. We take a little look at corner performance. You can see even when these features such as the Boogeyman are blown up to full screen size, Even when placed in the corner, there's a lot to see, you know what I mean? Stellar profiles, that is to say the shape of these stars, are holding up really well, even with no corrections applied whatsoever. So this is absolute top left, just to give you a demonstration. In HA, now HA is a very sharp channel by its nature, but I'm starting with this. I'm going to show you the others as well, but we won't dwell on them too long before we jump into some traditional one-shot color APS-C data to compare it with. But you can see sharpness across the whole field of view. It appears that Bill maybe's got a tiny bit of tilt in the top right of his camera. Can't knock him for that though, as getting all the tilt out of a full frame camera is a bit of a bear, to be quite honest with you. But that's the HA frame right there. If we just take a look in the same sort of capacity, the red frame, so we'll jump in on this now. You can see it's completely unprocessed. This is just an STF that's been applied to this master, so we can have a look at the data in its most honest, raw state, if you like. So this is the sharpness of the red channel going across. So we're taking a look now at edge sharpness and star shape, if you like. So it looks like in the reds, in the broadband, should I say in general, that stellar profile, as in the size of these things, is a little bit larger and appears to be at the very corners of the full frame, just that little bit more kind of deformed, if you like, but it's not much, and it would all be completely cleaned up again by BXT. And let's face it, nobody really spends much time just looking at raw data like this, but I think it is really useful when trying to evaluate a scope's native performance, because one of the key things for me, at least when I'm looking at getting older hardware, I want to spend as much as I feasibly can to get the best instrument that I can, as I believe that you know the higher the quality data that you put into processing, well, it's going to lead to a higher quality end result. So rather than getting something that's a very budget telescope and trying to polish it as much as possible with software, it does work. My personal approach is to get the best scope that you can going into things, do you know what I mean, and getting the quality up that way before you even move on to any further processing steps. So overall, there you can see the red channel, wonderful sharpness throughout, and also very nice illumination. These will have been taken with flats, by the way, as well, just to point that out. So these are calibrated frames. Now, just a quick one, we're going to take a look at this blue channel, 1:1. You see there's a little bit more of haze around the stars on the blue channel, as well as a little bit of maybe a more triangular commentary, appearance. I say commentary, you know, like the slight dispersion tail of a comet. Just reminds me a little bit of that. But overall, still, like I say, this would sharpen up just wonderfully once you get into the later stages of processing. But it is there. It's not quite perfect, so that's why I'm talking to you about it. I want to let you know everything I possibly can about this this telescope. So anybody who's thinking of buying one, that kind of thing, you can go into it well armed at least. So center sharpness, by the way, once again, this is on green. Now we're looking at wonderful edge sharpness. Actually looks a touch better corrected, I'd say, in green than in blue, but we really are splitting hairs at this point. Just like I say, I want to make you aware of everything I possibly can about this thing, as I know it's not cheap, and this is part of my job, innit? Give you the best information that I can. So if you want to spend any longer looking at these things, just please do hit pause. All right then, so if you'll just excuse the poor lighting conditions for this shot for a moment, I'd just like to talk to you a little bit about the overall build, fit and finish, and usability after 6 months of usage on this telescope. And I have to say, it doesn't disappoint at all. For a scope that's marketed at this price point, £1,350 here in the UK, you would expect it to be built very well indeed, really. And I'm happy to say that it is built very well indeed. Nothing disappoints whatsoever with it. And after all that usage, all those sessions, everything's still working exactly as it should. Nothing's needed adjustment or any such thing, you know what I mean? The dew shield actually has had some usage, pushing back and forth for storage and, usage. And again, that's holding up absolutely rock solid. That's in its extended position right there. That's a weak point on some telescopes out there, I have to say, but it looks like the makers of these have cracked the code a little bit. It's working absolutely perfect over time. The rotator held up wonderfully. The auto focus has never needed touching. It's just been kind of set up day one, and it's all just continued working, so there's been no slack creep into the system after many probably 1,000 plus autofocus routines, I would imagine, or something like that over this amount of usage. Yeah, just overall very, very happy with the mechanical performance of this scope. And I just thought it was worth pointing this out because obviously that could be one of the main reasons you're looking at spending a little bit more over something that you can pick a touch cheaper, you know, like a Skywatch 80 ED, just for example, which optically performs really rather nice, but is let down by its mechanics. This suffers really none of the issues whatsoever, to be honest. If I'd spent more on a telescope and it was still built like this, I'd still be happy. So I think that's a key takeaway from this. I think the only negative I have for you, something I'd like to see perhaps if ZWO ever did see this video, is perhaps the inclusion default, you know, in the box kind of thing of one more finder shoe. I think that'd be really, really useful for this telescope, as at least for me, when trying to set it up the first time for use with a, you know, an ASI Air and a separate discrete guide scope solution. I had a bit of a difficult time, to be honest with you. So yeah, I think that'd be just make that step more usable, which is probably, let's face it, if you are looking at purchasing a small refractor, you're looking for reliability, usability, and that would, you know, be an extra step towards it just being an absolute top tier experience all around. But it is very, very good as is. So yeah, top marks really there, just about. Now, if I'm going to show you where I think the scope is at its absolute strongest, and that is on APS-C. So this was a 2600 MC Air. This is just, again, stacked masters and no processing whatsoever applied to these. These are just literally STF stretched as they are before even being cropped. So I want to show you what we're looking at here. Now, I'm going to point out, like I talked about earlier, you could take this data right here, which looks pretty good, and take it a heck of a lot further. But I'm not showing that for all these images because I just don't think it's quite honest maybe to do that, as my, you know, time spent processing, the tools that I have access to is going to be different to yours. In many cases, you may be more efficient, less efficient, or not have the same tool set, or a better tool set. So it loses some validity. But these steps that have been applied to these, anybody could apply. So I hope that they stay completely valid for you now. Center sharpness, of course, much like we saw on Bill's, absolutely wonderful. Going out now, I'll just make this Andromeda data slightly bigger for you. Top corners, you can see that amount of distortion that we were observing before now is very, very minimal over the size of an APS-C image circle. So this is where you're going to be getting the absolute best from the scope for my money, even though, as you can clearly see, it does perform well still on full frame. Bottom right performance right there. Top right performance. You can see a little bit of what we saw in those spot diagrams, by the way, as well. Slight fringing of red to one side, blue to the other, radially throughout. So there's nothing wrong with the telescope. It is performing as the spots would suggest. But yeah, like I said, I just want to point that out to you. So let's move on, take a little look at M81, M82. This is some deeper data now. So this is a little bit, you know, longer on the integration time. As you can see, 372 3-minute subs. So this is now taking a look at reduced data. By the way, all the data that we've just looked at before this was taken native. This is now reduced data, taking the 0.76 times reduced. So we can see small clusters of background galaxies beginning to be resolved, even from my very unconvincing Bottle 7 skies here. It just seems like with enough time you can kind of brute force results a little bit. Now, one thing that's really interesting to me about this telescope and kind of cements what I was talking about just a little bit earlier about getting the best that you possibly can, and that being the way to go, is even some features such as this small background galaxy right here. We're going to take a look at this with a little bit more processing applied. And it's something that usually when framing up an image, let's say like this one, I wouldn't pay any attention at all, you know, to the positioning of this kind of thing in the frame. But these days, if I was using this again, I might have to, because stuff like this can actually start to look really surprisingly good with a sharp enough optic. So this is just a little 80mm eye on the sky, and take a look at the quality of what's being resolved in the corners even of this thing. I wish I'd paid better attention to framing this. Had I known how good the optics are, I would have done. You know what I mean? But here we are. It's hindsight's always 20/20. Now, as you can see with the reducer, we are getting just a little bit more of that dispersion. These images are not color corrected, by the way. I want to leave that out there just to let you know that it's a deliberate thing. I'm showing these not color calibrated, as that would hide some of this, and I want it to be actually fully on display so you can see the data in its rawest form as we analyze this. You see a small amount of the star shape there changing. I think its performance overall is probably maybe at its best. This is splitting hairs now. This is an interesting little galaxy as well later on, but this is really splitting hairs, I guess. But at least APS-C doesn't matter. Use it with the reducer, without, doesn't matter. I would probably expect, looking at the corners of this APS-C reduced image, by the time you get to the edges of a full frame, it might be a little bit more extreme and perhaps not quite as convincing for me, but without data to test, I can't say for sure, but that's just my gut feeling, looking at the corners of APS-C and then trying to extrapolate from that what I imagine going out another good way, again, might do to the stellar profiles on display. But overall, nice data. And once again, like I say, this is completely uncalibrated in terms of color calibration. So never mind the green cast on this one. This is we can't judge star color, unfortunately. This is dual narrowband data taken with the reducer and the 2600. Now, center sharpness, very, very good. Being dual narrowband as well, we're restricted to just HA03. So two very different wavelengths of light to focus. And as you can see, it's doing a rather good job. There is a little bit of fringing on one side and the other, as we expected. Again, looking at those spot diagrams, it's kind of just the expected performance without having to go over what I'm saying too much there, but no surprises effectively. But if that kind of thing does bother you, you may have to spend another £1,000 and go up to like the SQA, that kind of thing, in order to get rid of this. I think this is still an incredible performer though, and you shouldn't write it out. Now, one little thing I have noticed about this, and my friend Bill talked about this to me when I was putting this review idea out there to him, and he said he's had some issues with reflections in his data, particularly when taken under quality skies. So you'll notice there was no reflection issues whatsoever with the broadband data, but as soon as we move on to a little bit of dual narrowband data, there is, in my data right here, a very small reflection crept in from somewhere. And if we just take a look really quickly at Bill's data once again, so the red doesn't show it too much, the green, there you go, you can see there's a kind of a ghostly reflection halo going on up there. That's not data that is captured. That is, unfortunately, one of the lens elements being illuminated from the side, I suppose, by an off-axis star. You can see it actually starts up in this corner, very narrow, broadens and streaks out throughout his image. Now, this was a real problem for Bill. It bugged him so much he's actually recalled his telescope now from Starfront in order to try and deal with whatever's going on and decide what he's going to do at this point. But this is important stuff, you know, we do need to highlight this. Off-axis flaring is possible. It can be corrected if you are willing to place, you know, little inserts in to step down the aperture ever so slightly, but I really don't think you should be having to do that. But I just, you know, wanted to point it out to you, let you know about it ahead of time. It doesn't seem to be a huge issue for most people, but if you are imaging under pristine skies with bright stars just off the side of your framing, it could be an issue, so I'm making you aware of it. Now, this is a little bit further on in processing, and this is where we are going to try and wrap things up a little bit further on. So I know we've gone on at quite some length, but please do bear with me for just a moment. So again, this Andromeda data, now we are taking a look at it after GradientXpert has been applied, BlurXTerminator and NoiseXTerminator has been applied. So nothing much in terms of, you know, nothing dramatic's been done to this data, but it gives me an opportunity to show you how this data reacts to those processing steps. It's really really common processing steps, stuff we're all really going to apply, I would imagine, if you're imaging with this kind of a telescope. But if we just zoom in like a 3:1 on one of these little small segments of the Andromeda galaxy right here, so this clustered region right here, now we apply BlurXTerminator, NoiseXTerminator, we've suddenly got really convincing data to work with, you know what I mean? Because it was good going in the first place, it looks all the better by the end. And once again, if we just give you a quick demonstration of the mild shape change in the corners on these images, it's very, very, very minor. But like I say, it's an expensive telescope, so we need to talk about it. But you can see a little bit of shape change right there. And if we just apply now BlurXTerminator, you see how it takes care of it. NoiseXTerminator, and suddenly, right to the edges, you've got a fully workable image. And that's how that polishes up. Now, this is quite an interesting one, I think. Going back to what I was talking about with the need to be a bit more careful with framing, as you might pick up unexpected things that you wish you'd framed better. So again, uncolor calibrated data, this is just the same thing being applied, but this is now with the reducer, of course, as we talked about, this M81, M82 stuff. It's still linear as well, this is just an STF stretch that's been applied, but that background galaxy we were talking about now, if you can see, it stands beforehand, and it just gets polished up that little bit extra. Now it's a beautiful target even in its own right, even though I think on most scopes you'd be hard pressed to even pick it out against the background as much more than a blob, whereas on this we have got some shape, we've got some structure, we've got some distribution of color. I think, like I say, it's thanks to the quality of the data going in the first place. You can see what it's had to work with, like when we take a look at this corner, if you like, going back, there is a lot of flocculent detail. There is some small cloudy stuff going on in there. Reapply those tools, and it's just brought out. As I talked to you just before about one of these corner galaxies just down here. This is an interesting little target, I think. Once again, there's shape, there's distribution of its mass clearly visible. These arms spiraling out, you can trace them quite easily. And look at the size of the feature in context with the rest of the image. It's that tiny little thing next to that star. I think it goes a long way to demonstrating the power of a quality optic. So, it doesn't have to be the ZWO FF80 Apo, but I am demonstrating the point that these days we have access to such incredible telescopes at reasonably affordable price points, this thing included. It's a lot of money, but it is a lot of scope. The things you can do with them can really change the game, I reckon, and how you actually are going to have to start approaching imaging, how carefully you're going to be framing things going here on out. So, all that said, I think this is an incredibly promising telescope. If I was in the market myself for an 80mm Apo quad refractor, or maybe a quint or something like that, I'd be looking myself at this and the SQA85 most likely, and trying to weigh up whether the extra £1,000 is worth it to me. It might be because I'm absolutely mental about astronomy, let's be honest. But once again, you can see this is just very limited data, by the way, taken from a dual narrowband filter, and it's nice. There's a lot going on, and it could be processed so much further than this. None of these images are taken, anywhere near what they could be. This is all just demonstration stuff. Like I say, if you want to spend some time actually processing, you're going to come up with really beautiful images from this telescope. It can do an awful lot. Certainly enough to convince me. So yeah, let's leave it at that. Long enough outro to this video now. Look after yourselves, guys. I look forward to seeing you in a future video. Bliss, guys.